consecutive nodes from a linked list. Okay, it's a linked list problem. So usually we have some pointers and stuff, and then we have to use those pointers to move or iterate the linked list. We are given the head of the linked list. Usually we are only given the head of the linked list, and we repeatedly delete consecutive sequence of nodes that sum to 0. So first task is that you have to find some consecutive sequence of nodes that sum to 0. Okay, until there are no such sequences left. Okay, great. And after doing so, we have to return the head of the linked list, head of the final linked list. Okay, great. Now, and I may return the answer, any such answer. So let's see what I'm saying with the example itself. Again, that's given in the form of a list, but we will imagine this as a linked list. So we have 1, after that we have 2, after that we have -3, after that we have 3, after that we have again a 1. So now we can simply see we want consecutive sequence of nodes that sum up to 0. So by visual representation, we can see 1 plus 2 minus 3 will give me a sum of 0. And then, okay, 3, 1. But Aryan, why you did not take this sum? This is also a consecutive sum, which is giving you a 0. Bro, that's the first thing, that linked list always starts from left. So from left, the first consecutive sum of 0 which you will encounter, that you will remove. That's the first point. Again, because that can be confusing, you have to ask your interviewer that what he is trying to say. Although it's not directly mentioned that first consecutive, again, it's just this consecutive sequence of nodes that sum to 0. But it's never said, okay, first consecutive sum of zeros. So we can have that a quick check with the interviewer what he's trying to say. Okay, great, because it can be that he wants some smallest consecutive sum to 0, all that stuff. But yeah, we know that, okay, we have to remove the first consecutive sum which sums to 0. Now, if I ask you that there is one very basic way, that maybe you are at initial pointer and then let's say you are at this pointer, let's say start. Then you will keep on going until you can see, again, because you know that in a linked list you can only go forward. So one very basic brute force way is that you are at a start pointer, then you can keep on going and iterate on all the values until you find, okay, 1 plus 2 minus 3, okay, the sum has been, like the sum is 0. Then wherever you have ended, you can simply erase from start to end. That is the one thing. But Aryan, what if starting from 1 I cannot find any of the consecutive sum? No worries. Then you will move your start to next. Now your start is here. Now again you will again keep on moving in the end. So you can simply see I am at start and then I'll keep on moving. From that keep on moving, I'll check if I can find a consecutive sum and then that sum points or reaches to 0. If that is the case, great. If that is the case, great. I can simply from start to end I can remove those nodes. And what I mean by removing the nodes, as simple as that, if I am at the start, I have reached the end, I know from start to end the sum is pointing to 0. So the start's previous node, it should point to end's next node, because all these will be removed. So that's going to be a simple task. Oh, now from this fact itself, we have got many things out. First thing is that the approach which we saw initially, brute force approach, we were starting off with the start node and we're going on again on all the nodes again and again. So that's for sure a O of n square algorithm, which may be or may not be good. That for sure. Maybe we can improvise that. Now, this is one thing which we have seen so far, but one thing we also saw, that there can be a chance that we end up removing all the nodes in the beginning. Then what we should return? Head node, but head node is nowhere. So whenever, again, that's a fact which I have already seen previously. Whenever we have a chance that maybe head node, because ultimately in the problem itself, we are only given the head of the linked list, right? And we have to also return the head of the linked list. So anywhere that if we know that there is a chance of head being deleted or removed, then we always make a dummy head. Again, we make a dummy head when we know that there's a chance of our main head to be deleted. So we make a dummy head and point it to our this next node, this existing head node. I can do it without this dummy node also. Yeah, bro, you can do it. But for that, you have to put some if conditions just to make sure if your head is deleted or not. So if you want to get rid of those if conditions and want to make your code much more cleaner, you always should place a dummy node when you know that your head has a chance of being deleted. Okay, now we have got and seen one thing that okay, it's O of n square algorithm right now, and we are using head. Now, for sure, we are using a dummy node, which we will make in the beginning. Now, we'll come on and see, can we improvise it? Now, for improvising it, which means from O of n square, I can maybe reach to O of n log n or maybe O of n. For sure, O of n log n usually comes in when we can use either a search or a Fenwick tree or maybe something of that sort, maybe a merge sort or a Fenwick tree or a segment tree or a binary search. These are the cases when O of n log n, but there is no kind of searching going on. There is nothing as if I should be applying a Fenwick tree or a binary search tree, or a Fenwick tree or a segment tree, or maybe a binary search. I cannot do that. It's of no use because I need to do no search here. Now maybe I can reduce to O of n itself. Now to reduce to O of n, what I can do? My main task was my range sum should be a 0. Again, consecutive sum is range sum. My range sum should be 0. Can you find out any algorithm which you have studied so far which can give you a range sum in O of 1 time? Yeah, that's a prefix sum, because prefix sum says that okay, I can have, let's say if I make a prefix sum. Again, if you have not known the prefix sum, that's a good point that you should learn it right now. But to find the range sum in O of 1 time, we use the prefix sum approach. This prefix sum approach says that, okay, let's say in the very beginning, I have my sum as 0. So it just consecutively keep on taking the sum. Okay, I will have 1, I will have 3. Again, you will see I'm just consecutively adding the sum itself. Okay, now it's 0, now it's 3, now it's 4. So I just took the sum one by one, and I kept on adding. Now, anyone ask me, bro, can you tell me the range sum from here to here? I can simply go and say, bro, yes, bro, I can tell you. I can tell what's the prefix sum point at this point, and I can subtract this with my previous point. Okay, let's say it is my I, it is my j. Then I can say my prefix sum will be prefix sum of j minus prefix sum of I minus 1. You can see 3 minus 1 will be a 2, and you can see 3 minus 3 plus 2. The prefix sum is, the range sum is 2. So my prefix sum helped me to actually find the range sum in O of 1 time. Any range you ask me, I can easily find the range sum. Now, vice versa is also true. Let's say if I ask you, bro, can you tell me the range sum which is a 0? Now, if I ask you the range sum, so this will give me the range sum, right? This will give me a range sum. Now, if I ask you, bro, can you tell me that the range sum should be a 0? The range sum, this should be 0. It means that, okay, I can simply place a 0 here. So my prefix sum of j, it will become prefix sum of I minus 1. So I just need to find two values of prefix sum which are same. If they are same, they will give me a range sum of 0. That's what I can derive backwards from my existing range sum approach. So here we saw, okay, if I have two values, as you can see 3, 3, these two 3 combined can give me a range sum of 0. Okay, as we saw also that 3 minus 3, it gave us a range sum of 0. 0, 0. Oh, it can also give me a range sum of 0. As you can see, minus 3 to 1 can also give me a range sum of 0. That is actually helpful for us. So what I can do is simply I can keep track of this prefix sum approach. I can keep track of this prefix sum. That, okay, right now, let's say I am initially at my, again, you remember I will put a dummy node, and to be inconsistent with my prefix sum, I can simply number this dummy node value as a 0, because I know my prefix sum also starts from 0, so it will be consistent. Although it's not required, it's not a hard and fast rule. Prefix sum, you can go like this also. In the beginning, you can place a 0. The dummy node value, you can place anything, minus infinity, 1, 2, 5, 9, anything, because ultimately we know it is never used. Ultimately, in the end, we will run dummy nodes next, because the dummy node itself is not useful node. But still, just to be consistent, I will place my dummy node value to be a 0. Now, in the very beginning, I will just say, okay, my pointer is pointing here, right? Let's name the pointer as S, or let's say P, and I'll just keep on moving. As I keep on moving, I'll keep on increasing my prefix sum. I'll not pick an array specifically for that. I can make an array if I want, but I can just simply keep on increasing my prefix sum. Okay, prefix sum. Okay, prefix sum. As I keep on moving, I am adding my prefix sum. Now, what I want is, okay, if I have reached a prefix sum of 0, I have to go and find out if I have existingly found a prefix sum. Oh, so for that, okay, just to know if you have found something existing value which is same, how will you keep track of that existing value? Which means I'm just saying that you have to keep track. Okay, have you found a 0? If yes, okay. Have you found a 1? If yes, okay. Aryan, what is if yes, okay? If yes, where? Because if I have found a 0, I have to make sure, okay, I am pointing here. Because if right now I am pointing at -3 and I am at 0, I have to know where was the existing previous 0 found and what was it pointing to, because I know between those, which means from here to here, I have to remove all these values. I have to remove all these values. That's one thing I know. Oh, that's true, bro. That's true. That's super true. I have to remove all these values. So ultimately, I need to keep track. Okay, if I have found a value and also that value was pointing to what node. So it's kind of, I need to know the value, which is the prefix sum. I need to know the prefix sum value. Let's say prefix sum value, and that value was pointing to which node. So what is that data structure which I should be knowing? One thing, from a value to the existing node, I can simply use a map. And that value is present or not, map also will simply work for that also. So I know, okay, now one thing I have made sure is that I can simply use a map. It will work both ways for me. It can help me to know if some node existingly is there or not in my map, and if yes, then which node it is pointing to. So what I will do is I will keep track. Okay, my map of 0, again 0 is the prefix sum value, is pointing to dummy node 0. Let's say I'm not saying the node value, I'm saying dummy node itself. It is pointing to node itself. Aryan, why you want node? Why don't need a value? Because bro, I want that from this node I have to point it to my current nodes next, because I have to remove all these nodes. So I know the entire node structure itself. I just don't need the value, because I have to delete also, point to other nodes also. So I just need entire node structure. So what I will do is I will keep track of the entire node. Let's say 0 star. Star means okay, 0th, that node, specific node, I'm just taking the entire node itself, or you can name it as A, B, C, and so on and so forth. So the entire node A is with me right now. Same way, map of 1, entire node B, map of 2, entire node C, map of 3, sorry, -3. Again, Aryan, you did one thing. It was a map of prefix sum. Yeah, I have to keep track of map of prefix sum. Now, map of 0. Oh, as soon as you encounter to any node, please go and check if you existingly have a node. If you existingly have a map key value pair with the existing prefix sum. Because if the existing prefix sum is there, you know that you should not update it right now. Firstly, have a check if you have existing prefix sum. If yes, then bro, simply at the first point, remove it, which means I'll go and point here. Now I will have my start node pointing here. So I'll come back and I will point my start node back here. Then this is my current node which I am at. Let's name it as head right now, because I can simply keep on moving my head. Why? Because I have already have my dummy node, which is for sure pointing to the very beginning, and in the end I know I have to point the dummy nodes next. So head is no more required for me. So I can simply use my head as a pointer to just keep on moving. Now I know that I have to just do one thing. From this start node, I have to just simply say starts next is heads next. So I'll just say starts next is just needs to be head next. So Aryan, which means okay, now I'm done. So I can simply say all these can be there. I can simply update and say, because all these are gone, so I can simply skip this and I can simply keep on updating and say okay, map of 3, you will again end up saying okay, map of 3 is the prefix sum. You will update that and say okay, this is the current node. It's a D node, it's a E node, it's a F node. So you will say it's a E node, but then you might go and end up checking in your map itself, it will point to a C. So what you might end up thinking is that you still have a node C where the prefix sum is a 3. But bro, you forgot one thing. While you were pointing from your dummies next to your heads next, you are actually deleting all these nodes in between. If you're deleting these nodes, so these are no more there. These are no more there. So it's not only all the middle nodes are just gone. It is also that their map values needs to be erased from the map. So what I have to do is I have to put a temp. I have to put a temp here. Temp. And that temp needs to be keep on moving until it reaches the head. And again, it's simply saying, okay, while my temp is not equal to my head, I should keep on deleting. Again, Aryan, my temp is pointing to start. I should actually point my temp to this. Yeah, bro, correct. So I actually say that my temp is nothing but my starts next. My starts next. So then my temp should keep on moving until it is equal to head, and then it should remove all the map values. So it should remove my this map of 1, map of 2, and sorry, my this map of 1, map of 3, and map of 0. It should remove that. And ultimately, I am just done. I will simply remove all these. Sorry, I'll just simply remove all these. All these are gone. No more required for me. And I can simply keep on going forward. So map of 3, I'll check. Okay, there's no more map of 3. So for sure, simply move on. Okay, map of 4, map of 4. Again, there's no 4 existingly. So simply move on and put a F. And that's how ultimately, in the end, I will have my final linked list, which is, okay, dummies, and all these nodes are just gone from my picture because all these are deleted, and then 3 and then 1. I know my new head is E, so I'll just simply say whatever is my dummy nodes next is my actual answer. So my final answer is dummy nodes next. Now that's the entire thing. We went stepwise. Firstly, we found out what's the requirement of the problem. Then we found out, okay, we want a range sum. Then range sum, we have prefix sum to get the O of one time. Because earlier we were actually, to get the range sum itself, we were iterating. We were doing a O of n square. To get backtrack, we use a prefix sum approach. Then we went inside prefix sum and we figured out, okay, prefix sum gives us, okay, range sum. But we know right now, range sum will always be 0. So for sure, I can simply say that both the values of prefix sum needs to be same. To keep track of those values, I just took a map here. Map will keep track of key. Key will be the prefix sum value, and value of that map will be my node pointer. So now I will be knowing, okay, from start to end, which means from start to that specific prefix sum value, I have to delete all these nodes. And ultimately, I will get my final answer. Now, let's take one more example. This one thing I have missed, and that's a question for you ultimately in the end. Aryan, you just erased from the map. You just pointed your starts next to your head next. But Aryan, what about these node values in the between? Do we have to free up the space which was taken by them also? Yes, you should. But we will see. Although, like, no one will teach it, and I also tried this fact. When again, this node which you made, the dummy node which you made, you can delete that, and then compiler will say nothing to you. But if you end up going and deleting these nodes, compiler will end up giving you some values that it will say heap use after free. It ultimately says that you are using a heap space when you have deleted that space. So we will see that, okay, what is the problem and stuff, but yeah, it will not affect your answer or all that stuff. It is just the extra part which we will see in the end. And that's a question for you also, because I tried for 2 hours just to delete or to free up the space, but that was giving an error. Now, coming on back, let's do a quick example. 1, 2, 3, minus 3, 4. 1, again, we'll simply make a node structure. 1, 2, 3, minus 3, and then a 4. We saw that whenever we have a chance of the head node being deleted, we just simply make a dummy node. Here in this case, to just be safe, I will make a dummy node of my node 0 value. I will keep track of my prefix sum. Prefix sum right now is a 0. Okay, so I'll simply say that map of 0. Again, let's name. Okay, it's node A, node B, node C, node D, node E, node F. So I'll simply say prefix map of 0 is nothing but my A. Now I'll simply move on. Again, my head is keep on moving. It is my dummy node which is pointing here. Now it is my head. I'll keep on moving my head until my head is null, and you know it is null. So I'll simply say while my head is not equals to null, simply keep on moving your head. Simply keep on moving your head. What I mean by simply moving my head? Simply head is equals to heads next. That's your basic task. Head should be keep on moving until it becomes null. So that's a basic structure. But now I will move my head. Now as soon as I move my head, which means my head will come here. Simply my head will come here again. My head was already pointing here. Dummy node I just made. So in the very beginning, I can simply say fun fact that okay, let's make a new list node, which is nothing but a dummy node. Let's say DN, dummy node, and that list node will be a new list node with a new value of 0 that I have made. And I also know that this dummy node's next will be pointing to my head. In the very beginning, nothing I have done. I know I have to also make an unordered map or a map. Usually we take unordered map. So I'll also know I'll make an unordered map, and I'll simply say that right now the prefix sum will be the key, and it should point to my actual list node itself. So I just made a list node pointer. It should point to list node itself, and let's name it as a map. Now in the very beginning, my map of 0, as you can see in the very beginning, it is pointing to my dummy node, and you can also see the prefix sum value will start from 0 itself. So map of 0 is right now pointing to my dummy node. So the basic stuff is done. Now your head is right now pointing here. So you should keep track of this prefix sum, which you were keeping track of this prefix sum. So I can simply say that, bro, I'll do one thing, that in the very beginning, I can simply take another variable, that int prefix sum, let's say ps prefix sum. In the very beginning, my prefix sum is 0. So as soon as I am on this loop, I'll simply say prefix sum is nothing but prefix sum, simply adding the prefix sum value with the new node value. So I'll simply say prefix sum plus head value. So I have added a prefix sum value in my, I have added a head value in my prefix sum. Okay, now one is added. I have to now update that in my map. So I'll simply should do map of the node value, which is head. The map of prefix sum. It should be my head. That is, I have to update, right? I was simply saying map of prefix sum should be pointing to my node value, like list node pointer. So I should do that. I can update that if it is not there in my if it is not already there in my map. So first you have to check if map dot find, again that's a if condition, if map dot find, if that specific prefix sum is not equal to, okay, it's fine, it is fine, it is not equal to map dot end, which means I have that prefix sum value in my map. If I have that prefix sum value in my map, then bro, starting from, okay, right now you are at head, which means right now you are at head. So you have to go and check the previous location of that prefix sum, because it is the prefix sum. You are at head. You have to go and check the previous location of your prefix sum, which is this. Let's name it as a start. And from here to here, you have to delete all these nodes. That's your task. In this if loop, if it is not there existingly, simply in the else loop, you can simply go and do one thing, that okay, map of that prefix sum is right now pointing to my head. That's a simple task. Now, this deletion, as I already told, it's a simple deletion that you know that right now you are at this specific prefix sum. Here is your head, which is being pointed to. You can simply go and find wherever, again, simply by using your map, wherever your existing prefix sum was pointing to, it will give you a new pointer, let's say start. Just simply asking your map, bro, can you please give me a list node pointer, let's say start, where you have your existing prefix sum value. He will give you a start pointer. And now you know that from starts next, which is, let's say you name it as a temp. From starts next up till this node, remove everything from the map. You might end up also thinking, I'll also free up the space of these nodes. You can't do that, but be safe, because things go very bad when you delete memory. I'll show you, but yeah, right now your main task is just saying, okay, your starts next should actually points to heads next. That's your main task. So my main task is first fact is my main task is my starts next should be pointing to my heads next. And also any node which is in between, which means from temp to head, all these nodes, I should say that map of their corresponding prefix sum, whatsoever is there, whatsoever is the prefix sum there, let's say PS1, PS2 and PS3 and so on and so forth up till this PS value, I have to simply keep on erasing those. This I have never not even made in my map right now, so I can simply ignore this because this is not even made in my map, this prefix sum value. But for the other ones, I have to erase that in my map. So I'll simply keep on iterating on all of those from my start to my head and simply erasing all these prefix sum values and simply say map of this value dot erase. And thus I will be simply erasing this. So these two are the main tasks which needs to be done in this specific if condition. Now simply iterate on the entire from start to head just once. Once you iterated just to reach head, and then you might end up going backwards from start to head again to just erase it. Aryan, is it not O of n square? As soon as you have deleted some nodes from the map, you will never go on to them, right? So you delete something once, which means you land onto that again and delete that. That's it. So one time you land onto a node, just check. Again, in worst case, you can land back again to a node just to delete that. When something is deleted, you will never come on to it again. That's like your relationship. Cool. So that's the basic structure. Ultimately, in the end, return dummies node, which is dn for us. Next, that's a final head. Let's see the code. It's pretty simple. So as I told you in the very beginning that I have a dummy node, which is a new node, new list node. And then I simply said that my dummy nodes next will be my head itself. Now I took an unordered map, which is simply a map. And that I simply said just to keep track. This is my prefix sum value. This is my prefix sum value. In the very beginning, I simply said, okay, prefix sum of 0 is nothing but my dummy node. And I set prefix sum of 0 so far is 0. I kept on moving while my head is not equal to my null. And you can see in the as soon as my while loop is ending, I am saying head, just simply keep on moving. That's a basic structure to just simply keep on moving your head pointer. Imagine then when this entire portion is done, you just know one thing, that you have to return your dummy nodes next. But you also know that you made this dummy node, so it's your responsibility to delete that dummy node. So it is your responsibility to delete that dummy node. So I simply took that and took, okay, this is a new head which I have to return to my answer. So I can simply return that answer. And as I made this dummy node, so I simply deleted this dummy node. Okay, great. This is what you will do. But the main crux is in the while condition. While my head is not equal to my null, I'll simply keep on adding my prefix sum. Okay, my prefix sum will be simply, as we will keep on going, I'll keep on adding my prefix sum. Now this prefix sum, if it is not there, if it is in my map, okay, do something. If it is not there in my map, then simply add it in my map. That's it. If it is there in my map, then things gets to start tricky. Now when I'm saying my prefix sum, right now my head is here, I'm saying my prefix sum is in my map. So if it is in my map, go ask what is the pointer it was pointing to. So it was pointing to my start. So now existing prefix sum was there and it is pointing to my start. So I got this start node, and I know from the start next to this head, I have to delete all these nodes, and simply ultimately starts next should point to my head next. That's my main aim. So you'll see my start next is pointing to my head next. That's the main aim. But now my other aim was to delete all these nodes, which means ultimately deleting, that's a second task to just free up the memory. But main task is erase from the map itself. So my main task was erase from the map, which means, and again, map contains keys. So I can just simply erase from the map when I know the keys, and my keys are nothing but the prefix sum values. So I have to get those PS1, PS2, and I have not been keeping track in any array or stuff. Right, so I have to build this prefix sum again for this, all these. So I'll simply, so right now my prefix sum was there at the start node. I know the node value. I'll simply add the prefix sum with the node value, current node value, to get the new prefix sum. Then add the existing prefix sum with the node value to get the new prefix sum. That's how we make a prefix sum. So I'll keep track of the prefix sum. Let's say PF right now, and currently my temp node is here. Although you can point your temp node to here itself directly, but yeah, I put it like this. You can put it anyway. I put it my temp here, and then in the very beginning I just ask if my temp next is not equal to head, and then in the very beginning itself I'm pointing to my next node, because I know I have to start off with my next node itself. This should be my actual temp itself. So in the very beginning my temp was at start, which is here, but as soon as I entered the loop, I pointed my temp to the next value, which is actual main value, which I have to start deleting. And then I will simply add its value to my prefix sum to get the new prefix sum, which is PS of 1. This is the existing value. Let's say this is the existing value. I added in my existing prefix sum to get the new prefix sum, which is PS1. And then this PS1, I simply erase from my map. Now you might ask, Aryan, that seems completely fine. The main two tasks, which is pointing your starts next to your head, pointing your starts next to the head next, you have done, and also you have erased everything from the map, because map you made and pointer you have to make. I think you missed one thing: deleting of these middle nodes. You did not delete those middle nodes in the bit in the middle. Yep, that's true. Remember that in the end we did not delete that. But yeah, so far we have seen this was the condition for us, and ultimately we just remove the dummy node and return the dummy nodes next, and that's going to be our answer. So you know the time, as you can see, it is O of n to return all the nodes. In worst case, I will check the prefix sum is existingly there. I will go back. I'll again iterate on this portion and delete all the nodes in between. So again, it's O of n time. Now space for sure, nothing but I am using an unordered map to keep track of all the keys, which means prefix sums, and their corresponding nodes. So it's nothing but again O of n space. So roughly it's O of n time and O of n space what we have achieved. Now, so far the question is complete, and ultimately for all these solutions, even if like people might not tell the brute force ones, but still people will end up here. Now the thing is, you might end up thinking, Aryan, you deleted this node, although people might not even delete this, because then you will have a doubt, why did you not deleted this node which was in between, in between. Now that same condition was, I tried a lot to delete that and everything. Again, I used the debugger mode also. In that extent I went on to this, but I tried deleting these all, and you can see as I was telling that you can also put the temp, like start next as a temp, because you know that you just have to delete that temp node. I knew I have to delete this temp node. I tried to delete this temp node here itself. I could not delete it. It gave me the same error, heap use after free. Then I thought maybe it is trying to use it, so in the very end I should delete that. So I put in all those pointers in a new vector. I made a new vector and I put in all those list nodes, and then I thought maybe in the super end, in the end itself, I will delete those nodes. And I could see up till this point, up to the last line 64, everything was working exactly fine. And again, it is not that okay, new head was keeping track or having that node. It was not having that node. Still, when I tried to delete this, everything was working fine up till that point. And you can easily see that if I just right now tell you, and like again, that's a plus point of having a premium, that okay, in the worst case, if you are still confused, then you can actually get the debugger on. So you can simply see that finally everything, after doing everything again, I just went in completely. So my actual dummy node is having some random value because it's the action memory is deleted, so it will just give me any value. Okay. Prefix sum is there, vector is completely empty, my map is completely empty. Again, I have deleted those and then made it empty. I have deleted those and then made it empty. That's what I have done. Now I simply return my head. Now you can see my head only contains my 3 and 1. There's no other nodes. So how can, again, everything was working fine. Ultimately in the end, you will see that you will actually get a heap use after free on address. Usually this error comes in when you are trying to use, okay, like I read many of these blogs and stuff, when you are trying to use it after deleting this, then if you're trying to use it, then it usually comes in. But still, no way I could figure out. Maybe it's something because of Leetcode, it happens, or something like that of sort. But yeah, that's a question for you. If you can help out, a huge shout out to you. But yeah, it's an issue which I tried for 2 hours, but still I was just still confused on why I cannot delete those middle nodes. Maybe Leetcode wants it as its own memory and they cannot, they don't allow us to delete that. Maybe that's one case. Everything which I make, I can delete that. That's true, and that I did in my dummy node also. But for the ones which was existingly there, I could not delete that. Maybe that's the case which I could think of. But if anyone has any other solution, please help down below. That will be great help for the community also. Cool. Bye bye. Thank you so much. And yeah, please answer that.